You ever stop and think about what happens when you tap login or buy now in an app? Well, there's this invisible bodyguard working on your phone, pretty much 24/7, to protect your data. Today, we're going to pull back the curtain on that bodyguard. It's called App Transport Security, or ATS, and it's the digital shield you probably never even knew you had. So let's start with the most basic question, right? What really happens when one of your apps needs to talk to the internet? When it's fetching your messages or your bank balance or just the latest news. It's having this constant conversation. But is it a private one? Because you got to understand, before Apple really stepped in, the internet for a lot of apps was basically the Wild West. Your data was just out there, traveling completely in the open, totally exposed. And we are not talking about small stuff here. We're talking about your login details, your personal info, your payment data, even those little secret tokens that keep you logged into your favorite services. All of it could be flying across the internet completely naked, making it just shockingly easy for someone to snatch it right out of the air. Here's a great way to think about it. Sending unencrypted data is just like sending a postcard. The mail carrier can read it, your neighbor could glance at it. Literally anyone who gets their hands on it along the way knows exactly what you wrote. There are zero secrets. So yeah, this was a massive problem, and Apple knew it. So what they do? They decided to hire a digital bodyguard for every single app. So let's meet App Transport Security. Now, the key word here is enforces. ATS isn't just a friendly suggestion, it forces apps to use secure connections. And maybe even more importantly, it blocks the insecure ones from the get-go. Think of it like a bouncer at the door of your app's internet connection. If you're not on the list, you're not getting in. And get this wasn't some recent change. Apple rolled this out way back in 2015 with iOS 9. This was a huge shift. They basically decided that security shouldn't be an afterthought, something you tack on at the end. It had to be the default setting for every single app on the platform. Okay. So how does this digital bodyguard actually do its job? What's on its security checklist? Let's dive in and take a look. It really all comes down to three simple, non-negotiable rules. First, apps must use HTTPS. Remember that postcard? This is like putting it in a locked metal briefcase. Second, the server the app is talking to has to show a valid ID, a trusted certificate, to prove it's the real deal. And third, the lock on that briefcase has to be a modern, unpickable one using what are called strong ciphers. Basically, the best locks money can buy. And just look at the difference. With the old way, HTTP, your data is just plain text, super easy to intercept, totally vulnerable. But with HTTPS, which ATS demands, it's encrypted, it's protected from snooping, and you know who you're talking to. It's really the difference between shouting your secrets in a crowded room versus whispering them in a soundproof vault. So what happens if an app tries to break the rules and use that old, insecure HTTP? The answer is simple, and it's powerful. HTTPS just says, nope. The connection is blocked. The data goes nowhere. That's it. Security is not optional. And it doesn't even stop there. It's not enough to just use HTTPS. ATS demands the best kind of HTTPS. We're talking modern security protocols like TLS 1.2 or higher, the strongest encryption methods, and even this clever thing called forward secrecy, which protects your past conversations even if a key gets stolen later on. It's all about getting rid of any and all weak links. Okay, so that's the tech stuff. But let's bring this back to the real world. How does all this code translate into a tangible wall of protection around our digital lives? So what are we actually being protected from here? Well, these are often called man-in-the-middle attacks. Without ATS, an attacker on the same Wi-Fi network as you, let's say at a coffee shop, could literally intercept your data. They could even change the information your app receives or inject some malicious ads or code. ATS is built specifically to shut these kinds of attacks down. Completely. This is also a huge deal for the people who are actually building our apps. Because ATS is turned on by default, it forces developers to think about security from the very beginning. It's not something they can just tack on at the end. It's baked into the foundation, and that means fewer mistakes and a much safer app for all of us. All right, let's zoom out for a second. Because this isn't just about one technical feature. It's about a really powerful philosophy, one that changes how we should think about digital safety. What this all boils down to is a fundamental shift. Security is no longer an optional checkbox that a developer might or might not tick. It's built right into the platform itself. And that automatically raises the safety level for every single app you download. Doesn't matter if it's from a huge company or just a single person working out of their garage. And it really all comes down to these 3 words: secure by default. It's such a simple phrase, but it represents a massive commitment to our privacy and safety. It's the core idea that drives features just like app transport security. And that kind of leaves us with a final thought, right? If our app data can be protected by default, what else should be? What other parts of our digital lives, from our smart home gadgets to our social media accounts, should have security that's built in, not bolted on? Definitely something to think about.